All right, in this next video, I'm going to talk about radical equations, or I could be calling it square both sides, because that's what we're going to do. We're going to square both sides of the equation. For the first example, I have a square root of x minus 4 equals 0. So to solve this, I'm going to first add 4 to both sides. And so I get the square root of x equals 4. Well, the x is trapped inside the square root, so if I square both sides, then I get x equals 16. Okay, and that is the solution. We can check our answer, and we get the square root of 16 minus 4 does indeed equal 0. So that wasn't too bad. Let's look at the next example. We have the square root of quantity 2x plus 81 equals 12. The square root is already isolated, so I'm going to go ahead and square both sides. So 2x plus 81, quantity squared, equals 12 squared. And now, what can I do? But I can now I've gotten rid of the square root, so I have 2x plus 81 equals 144. Now I can subtract 81 to both sides, and it looks like I'll get 63, and then I'll divide both sides by 2. I get x equals 63 halves. And so if you plug that answer in for x, you'll see that it does indeed equal 12. Okay. Now, let's look at the next example. We have the square root of 2x plus 1 equals 3. The radical is already isolated, so I can just begin to square both sides. So 2x plus 1, squared equals 3 squared. And now what I can do is I can just take off. I've taken off the square root, and that equals 9. I'll subtract 1 on both sides, so I have 2x equals 8. Looks like x equals 4. Again, we can check our answer to see that that's true. 2 times 4 plus 1. So that's 9. So we're saying the square root of 9 equals 3, and yes, that is true. Awesome. Let's look at another example. We have x equals the square root of 1 minus x. Well, the square root is already isolated, so I'm going to square both sides. Okay, and now what I've done is I have x squared equals 1 minus x. Okay, now I can't just determine what number that is, so I'm going to have to move everything to the left-hand side. X squared plus x minus 1 equals 0. And what I can do is I can determine using the quadratic formula or completing the square, I can determine what x must be. So I'm going to use the quadratic formula, which I described how to do in the previous video. So the b would be 1, so we get negative 1 plus or minus 1 squared minus 4 from the formula. 1, negative 1 over 2 times 1. Okay, now we have negative 1 plus or minus root. Now that's going to be 1 plus, so 1 plus 4, which is 5. So we found that it's negative 1 plus or minus root 5 over 2, and that's obviously why we couldn't just factor this polynomial right there. So that is the answer. So x equals negative 1 half minus root 5 halves, and negative 1 half plus root 5 halves. Now, something I want you to notice is that we have x equals a square root 1 minus x. So we're asking, what if you take the square root of it, that it would equal this x. It equals itself. And so we couldn't have a negative number here. We can't have a negative number here. So no negatives. Okay? We can't have a negative in this spot. And this is a negative number. So this is a negative number. So I'm going to have to let that one go. All right? So x is just going to equal this one. So one of the solutions has to go away, okay, because it's a negative number. And you will find that when you square both sides, what often happens is you lose a little bit of information by squaring both sides, and you might get two answers, and one of the answers doesn't work. So you have to watch for that, and the way to do that is to kind of go back and see if a positive or negative is going to work. All right, I think we have time for another example. Let's try this one. So I have 2 times the square root of n equals n minus 3. There's two schools of thoughts about how to do this. Some are pretty strict and say that you have to isolate the square root, but I say that it's okay as long as it's just a little coefficient that you can just go ahead and square both sides. Now what's going to happen here is that 2 becomes 4 because 2 squared is 4. So you get 4n. Now this is technically n minus 3, n minus 3. So we're going to get n squared minus 6n plus 9. I need to subtract the 4n on both sides. So I get n squared minus 10n plus 9 equals 0. Okay, I have a leading coefficient of 1 here, so I need to find the factors of 9, which add to negative 10. I think negative 1, negative 9 would work. So I get x minus 9, x minus 1 equals 0. So x equals 1 and 9. So that's what I found was the solution to that quadratic equation. I need to plug both of those answers in and see, just to make sure that they both work. So I'm going to check, does x equal 1 actually work? 2 root 1 equals 1 minus 3. Well, the square root of 1 is 1, so I have 2 times 1 equals negative 2. And no, that does not work. This does not work. So the 1 is going away. Does the 9 work? X equals 9. I have 2 times the square root of 9 equals 9 minus 3. Let's see. So the square root of 9 is 3, so I have 2 times 3 is equal to 6. Yes, that is true. So x equals 9 is the only answer. Why are we getting an erroneous answer here? It's because we squared both sides, but we had to square both sides to do it. We're just losing a little information when we do that. So we have to be kind of careful. So we actually have to check our answers. So when you get two answers, it's a good technique to check both of those answers by plugging them in to see if they actually work. Okay. Well, let's look at the next problem. Yeah. I think it'd be best if I do that problem in another video. So I'll see you in the next video.